take a seat.
Yeah, where exactly do I take this seat?
Just sit down on the chair. Okay. Now, I understand that you have some questions regarding the creation of the universe and the beginnings of life.
Yeah, bro, so like, how did you make the universe?
Well, I didn't exactly create the universe, no. To explore the creation of the universe, we must travel over 13.7 billion years ago. Now, here, there was nothing, just a vast space of empty space. And even though there are many cultures with different beliefs in how the universe was created, we have all come together to accept one theory as the most logical way of how the universe came to be. Let me introduce you to the Big Bang Theory.
Yeah, say less, like, I'm on season 7.
Excuse me?
I've watched season 7, episode 14, I'm on that one right now. Darth Vader meets...
No, that's not... Now, if you just listen, maybe you'll understand. Now let's get back onto the real Big Bang Theory.
Yeah, true. To be fair, like, the real Big Bang Theory was, like, back in season 1 and 2. It was before they added too much laugh tracks to the show and it just got a bit out of control.
No, just shut up and let me speak. You came to me, bro. Okay. Alright. Sorry. Okay, now let me take you back 13.7 billion years ago. And here, there was nothing. And the Big Bang Theory states that the universe began as a hot and infinitely dense point, just a few millimeters wide, but with enough energy to be classified as a supercharged black hole. And then everything became everywhere. That 3 millimeter supercharged singularity just started expanding, which, contrary to popular belief, where the singularity was thought to violently explode. No, we call this sudden expansion of the universe the inflation epoch. And after the sudden inflation and the separation of the 4 known fundamental forces, the universe started to cool, and then it continued to expand. This allowed the first subatomic particles and simple atoms to form. In the first 100th of a second, the inflation of the universe brought forward matter, energy, space, and time into the universe. Are you following me so far?
Yeah, what?
Anyway, continuing on. If we make T to equal the time after the Big Bang, to measure the points in time when things came to be, we would place the creation of time and space and the point where the universe was 100 million trillion degrees Celsius at T equals 1/10 to the 43 of a second later. Then, William, my friend,
Yeah.
this is where the fun begins. Time equals 1/10 to the 34 of a second later. The universe is just the size of a pea. Then matter in the form of electrons and positrons are formed. They collide with each other and release huge amounts of light. Now, when time equals 1/10 to the 4 of a second later, protons and neutrons then form as a result of collisions between smaller particles. And the universe was so bright at this point. And William, do you know why the universe was so incredibly bright?
Did you turn on the light? Ah ha 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 ha.
No! The universe was bright because light was trapped when it continually reflected particles. Shortly later, the universe was still expanding, but still cooling. Right now, the whole universe was roughly the size of our solar system, and there was still no such thing as an atom.
Atom sounds like such a nice name.
ATOM, the smallest particle of a chemical element that can exist.
Yeah, Atom's still a terrific name.
Alright, so where were we?
You were telling me about the name Adam.
No, you brought that up. Ah, yes, the creation of our universe. 5 minutes after the inflation, finally the nuclei of hydrogen, helium, and lithium form across a sea of electrons.
I knew there was water in space.
Are you doing this on purpose? Forget it, just listen. We are almost done.
Sorry?
It gets even more exciting if that is even possible. Now, we have a very noticeable jump in time, from 5 minutes after the Big Bang to 300,000 years later. And we can see that electrons, once moving insanely fast and having a high temperature, now it's slow and cool enough to be captured by the nuclei of hydrogen, lithium, and helium. And this creates the first atoms. And better yet, there was now enough space in the universe for light to expand out into the outer edges. And for the first time in 300,000 years, the universe was dark.
Where does the light go?
Ah, good question, my friend. Now, this is an explanation that is the only logical explanation that scientists have come to a conclusion on. And yes, theoretically, with so much light irradiating out of the trillion stars in the universe, it should be a blindingly bright space. But not all of the light in the universe is observable light. Some are absorbed and converted into other types of energy via kinesis or kinetic energy. And this manifests into motion or heat.
Oh yeah, bro. I see.
Now allow me to continue, we are almost done.
Yeah, bro, I want to learn about stars, bro. I want to learn about the cosmos. I want to learn about stars.
Yes, stars. Yes, that leads me to 200 million years after the Big Bang. Now, this is when the stars begin forming, and this occurs when gravity pulls them. And this occurs when gravity pulls atoms of hydrogen, helium, and lithium together, and nuclear reactions take place inside these stars. This causes the nuclei of all of the atoms to fuse together, forming heavier nuclei. And sometimes, around of some of the forming stars, clouds of matter cooled down and formed clumps together, causing planets. Then 1 billion years later, the force of gravity in this lumpy universe pulls matter towards regions which cause the first galaxies to form. And that is the story of the creation of the universe as we know it.
Beautiful. Wait, how? What? How do we know this? No one was alive 14 billion years ago, except for like your mum.
Brilliant question. Now as scientists we can only theorize, but we have built a string of theories that support the hypothesis of the Big Bang Theory. Now we have theories that support the Big Bang Theory. The first one I am going to be talking to you about is the redshift. It supports the Big Bang Theory, but it contradicts the steady state theory. The steady state theory explains that the universe can only expand if the stars and the galaxies replace the ones that moved away, as there is no explanation about how the stars and the galaxies could come from nothing. Now the amount of hydrogen and helium in the known universe supports the Big Bang, as the only way helium can be produced is by nuclear reactions that take place in the stars. 8.7% of atoms in the universe are helium, and this is far more than what could be produced by stars alone. Thus, the percentage of helium atoms in the world can be explained by the Big Bang Theory. Now the last theory to discuss is the afterglow theory. And this theory suggests that currently our 14 billion year old universe is 2.7 degrees above absolute zero. And it is said that anything with a temperature above zero emits radiation. The nature of the radiation depends on the temperature. Now Gamma predicted that due to the universe's temperature, it should emit an afterglow of radiation. And in 1965, engineers picked up a satellite noise coming from deep space. It was indeed cosmic microwave background radiation that was picked up from the satellites. And this theory therefore put an end to the steady state theory. And that is how we know, or believe, for that matter.
I love doing this interview so much. I'm so happy I met the real Albert Einstein, bruh. Like, you've been like my role model for years now. Like, thanks so much. Can I put this on Instagram? Chilling with my boy at Big Albert Einstein, bruh. It's gonna be awesome.